on dark field microscopy. But it's important to note that biological specimens in general, owing to the fact that they are made up of elements of low atomic numbers, generally have a transparent nature. And so, for example, if you look at onion epidermal cells, for example, very transparent, and by that, it's very difficult to appreciate the resolution because one, contrast is poor, and once contrast, which is the ability to discriminate details that have already been resolved, is poor, then it's ultimately going to affect the rate at which you appreciate the details that have been resolved. And a way to overcome this is through what we call staining. And so we stain the specimen in order to improve on contrast. And by improving on contrast, then we get a face-to-face appreciation of the resolution that has already been established. And so if you have a house and you've not painted it, you don't really appreciate the beauty of the house until you paint it. If you have resolution and contrast is really poor, you don't really appreciate the resolution better. But there's a problem. The problem is that in order to stain the specimen, we have to take the specimen through a lot of preparatory methods. And all of these preparatory methods will require that even at the end of the day, while we stain the specimen, we are going to distort the tissue, or the specimen is ultimately going to be killed. And so, owing to the fact that biology mostly leverages on our potential to study live organisms, in instances where we want to study the specimen live, then there is an ultimate challenge of not being able to stain because we want to study the specimen live. And if you're not able to stain, owing to the fact that you want to study the specimen live, you can't really also improve contrast that much, and you can't really appreciate the details that much. And so how do we get over this? So for example, you want to study live cultured bacteria or microorganisms in their culture. You want to notice the shape of the bacteria, you want to notice their movement and all of those things. This has to be done live. You cannot kill the specimen because that is integral to the kind of studies that you want to have. So how do you overcome this? And one of the mechanisms that earlier science of microscopy was able to develop to overcome this was through the modification of the normal light microscope into what we call the dark field microscope. So the normal bright field microscope was modified to form the dark field microscope. And the inherent philosophy or the principle underlying this is quite simple. They place what we call a stop patch, which is also an opaque disc on the condenser lens. And that blocks light rays from directly passing through the specimen. And so the light rays now tends to pass through the periphery of the object, like the edges of the object, and carry the shape of that particular specimen into the objective, and that is what is seen. So for example, if you study live cultured microorganisms, you might be able to appreciate their shadows, like their shape. You'll be able to experience their shape, you'll be able to see their movement and all of those things. You'll be able to notice if they are consuming the medium and all that. But the problem with dark field microscope is that while it's able to let you see this considerably well, it is not able to reveal internal details, owing to the fact that it blocks light rays from entering the specimen proper. But then it's able to give you a closer appreciation of how the specimen looks like in terms of its structure, in terms of shape, in terms of movement and dynamics and all that. And that considerably helps, for example, in live microbiological studies in that particular area. And so that is the dark field microscope. Why it happened that you had to invent such a microscope, and what it does, and what are the flaws. The flaws of this microscope is that it's not able to allow us to see internal details. And the benefit is that it allows us to observe live cultured microorganisms or specimens without staining them to some significant extent. And the way forward is to be able to allow such a microscope, once able to allow us to improve on contrast without staining, still be able to allow us to see internal details. And that problem is going to be solved by what we call the phase contrast microscope, and we're going to consider this in the next tutorial. Thank you very much for watching, and I'll urge you to share this video and subscribe to this channel. Thank you.